Hello students, welcome to the Old Time Biometry Show. Today I'm going to show you how to do a two-way ANOVA, and this is a two-way Pure Model 1 ANOVA. The example is one in which the speed that ants were moving through the environment was measured, a whole bunch of ants were measured. The environments can be categorized into two kinds, these ones that are cluttered, and then there's ones that are uncluttered. And the ants come in two kinds also. There's one that are kind of intermediate size and one that are called workers. And so we want to see if the casts differ in how fast they go and if that difference depends upon the microhabitat in which they move. Now I've fiddled around with the data already, and it turns out that log speed is a well-behaved variable and we can analyze it. So just to check up on that, let's go to Graphs and Legacy Dialogues, Box Plot. This will be a clustered box plot because there's two variables. Hit that, and then we want to go log speed as our variable, and then the category on the axis, the x-axis, let that be cast. And then the clusters are the microhabitats. You could switch this around if you like looking at it in a different way. So I click OK. And yeah, we compare blue to blue in the cluttered environment. It seems like the intermediates move faster than the workers, whereas if you compare red to red, it seems like the intermediate and worker don't differ much. Okay, so now we can do an analysis, and this is a general linear model. It's univariate because there's just one y variable, log speed. So we put log speed in here as the dependent variable, cast and microhabitat as fixed factors, and then we'll save the residuals like that. Click OK. Now, if we go back here, you can see this column here is residuals 3, and we can then graph those residuals. So analyze, descriptive statistics, p-plots, and it's this one. Residuals for log speed. Click on OK. And there it gives us a normal probability plot. Yeah, you know, it kind of waves a little bit, but it's basically following the diagonal. Once you've validated that, then you can move on to looking at the two-way ANOVA. So here's the two-way ANOVA. And the important part is this part. That's what you'd cut and paste into some other place. You can see that cast by microhabitat is significant at 0.017. So what that means is that the difference between the casts depends on the microhabitat through which the ants are moving. Once I've found a result like that, I can make a big deal of the interaction, and then I probably want to move on to do some analyses on just part of the data. So we'll do an analysis on just the uncluttered habitat, and then we'll do a separate analysis on just the cluttered habitat. So to do that, let's go back and have a look at this. It says clutterer. I want to just get those, and so I'll go to Data, select Cases, and this thing, if condition is satisfied, and I want to say if microhabitat equals clutter. Those, I want to select those cases. Hit that, and then now when we scroll down here, you can see that the uncluttered ones are being taken out of the analysis. So we're only looking at the cluttered data. Now we can go and analyze it for a two-sample independent samples t-test. like that. And the test variable is log speed. The grouping variable is cast. And then you have to define the groups, which is sort of a pain. Be it intermade and worker. Yeah, like that. So remember, this is just for the cluttered environment. And for the cluttered environment, we get a t-test that is highly significant. So the ants differ by cast in how fast they moved when they're moving through a cluttered environment. Now we can go back and redo this analysis in the uncluttered environment. If I can remember how to do this. So I think we add unclut there, and then we get rid of a couple things there so it all fits. Click, click, click. Hopefully that worked. So now it's gotten rid of the cluttered ones, and it's only looking at the uncluttered ones. Great. We go to Analyze, Compare Means, Independent Samples t-test. Yeah, all of this is good, right? It's the same thing. And now in that uncluttered environment, see, there's not even close to a significant difference between the casts. That's all I have to say about that. Good night and good luck.